Born on Christmas Day in 1642, Isaac Newton was an English scientist who was the first man to begin to understand gravity and light, and how forces work in the universe. In his life, he centered his beliefs into 3 laws that have never been proven wrong even today. He also invented calculus.
Isaac Newton was born on Christmas Day, and he was so small that he couldn't fit in a quart container.
Yes.
When a rocket is lifting off into space, the force driving it upward comes from Newton's 3rd law. The thrust of the exhaust of the rocket creates an equal opposite force going upward, driving the rocket forward.
Yes.
So Caleb's pushing off the ground creates an equal and opposite force, which causes him to move back and forth like that. Yeah.
I'm gonna just like come up when I'm like.
Kitty's using motion, and so is the dog.
Not really. I'll do the Go.
Newton's first law is that an object in motion stays in motion, or an object at rest stays at rest, unless acted upon by an outside force. Let me see it.
Law number 3. Every action has an equal and opposite reaction. For example, Caleb is trying to walk on this pole railing right here, and he's pushing down on it, and the pole railing is pushing up on him.
Action.
An example of Newton's first law is the planets continually rotate around the sun until they are acted upon by an outside force.
Inertia is an object's tendency to resist a change in motion.
Born on Christmas Day in 1642 in a small village between Grantham and Stanford in England, he went to Trinity College in Cambridge, studying nature of light and design of telephones. One day, an apple fell on his head in an orchard, and it got him started with trying to understand gravity and other forces. That is what led him to making his laws.
I'm Gus Siegel, and I'm with my father, David
Doctor.
A. Siegel, Dr. David A. Siegel, and we are going to talk about Newton's 3 laws. But first, what is your job?
I am a professor of physical oceanography at the University of California, Santa Barbara.
How do Newton's laws affect your work?
Well, they affect all of our work, I suppose, because that's the way things work on the planet. But I'm a physical oceanographer, so I study how currents work in the ocean and what drives them, what changes them, how they relate to climate, how they relate to changes in a warming ocean. And so I use Newton's laws every day as part of my work, because they describe mathematically how you can predict how currents are going to change. We use constraints of mass, momentum, and angular velocity to understand how the ocean works and responds to changes in climate.
What got you into science?
Well, I'm not very artistic. I'm not artistic. I'm okay musical, but I knew I wasn't going to be great at it. And I didn't like to write when I was young, but I really liked science, and I found I did very good in science. I got my undergraduate degree at University of California, San Diego in chemistry and in engineering sciences, and that's where I learned how to do fluid mechanics. So I like science because science is like solving a puzzle. I mean, especially if you're an oceanographer, because you only see what's on the top surface, and you can hardly ever see what's inside. And it's so immense, and there's so little known, especially about what goes on in the interior, and that's so important for understanding things like climate.
Newton's 3 laws are so cool.
Gravity, inertia, 2.
Apples falling from the sky.
Like an anvil up so high.
Newton's 3 laws are so cool.
Gravity, inertia, 2.